our third session of our TBC-Brinadd technology webinar series. We are going to have a live broadcast every Thursday through the month of July over one of our products in our family. Today we're covering Ultra DR SP, which are high performance drag reduction additives, are dry friction reducers utilized in slick water fracturing. If you have any questions or comments, you can post them in the chat section or the questions below. We will follow up at the end of the presentation. Today, we have Mark Luyster, VP of Technology, presenting our Ultra DR SP series. All right, the floor is yours, Mark.
Thank you, Kimberly. I just want to say, for over 50 years, we've been an accomplished global provider of solutions for non-damaging drilling, completion, workover, and fracturing fluid systems. Our goal is to deliver quality products and manufacturing services at a competitive price to meet your needs. We have managed a quality management system since 2000 and attained the standards for ISO 9001:2015. This system requires processes in place to assess external and internal risks, and we do that on a continuous basis. So our dry polyacrylamide is 100% active. This reduces the footprint and trucking costs. It hydrates rapidly, and it performs in fresh to high TDS brines to provide excellent drag reduction. These products are developed for on-the-fly application and are compatible with most additives in use. As solids, they reduce the HSE exposure as non-hazardous, non-liquid, and again, this minimizes trucking and rig traffic. Finally, their particle size can be customized to meet specifications. In a few slides, I'll show examples of drag reduction and viscosity. So we at TBC-Brinadd grind all our copolymers as shown previously. This grinding process produces a fine particle size distribution. As a comparison, the image on top is our grind, and the image on the bottom is a coarse grind PAM. In suspensions, the former distribution negates separation, mitigates settling of solids during transport, as well as long-term storage, and yields fast hydration as dry or as incorporated into a suspension. This ensures every lot achieves consistent and effective performance. As an example, this graph shows drag reduction for 3 different grinds of the same polyacrylamide. These flow loop tests were performed using a 10,000 TDS brine at 1 PPT loading. The first 3 minutes are displayed on the right to exhibit differences in hydration, and the 10-minute chart shows the drag reduction differences with respect to sustaining with time on the left. Green line represents an unground PAM as received. The blue line represents PAM ground to a specified spec. This could be a request for a project or is received from a manufacturer. The red line represents PAM ground to TBC-Brinadd spec, which is then incorporated into any one of our Ultra DR series. So the optimal grinding produces polyacrylamide that produces 2 characteristics: increased surface area and rapid hydration rate. These can be measured indirectly by the time required to achieve 98% of maximum drag reduction as shown in the table. Note that the red vertical line exhibits near maximum drag reduction in 2 seconds. The 98% max value is the difference in time from the start, time 0, to where drag reduction is 98% of the maximum. For this test, 81.9% is the maximum drag reduction, where 98% of this value is achieved in 2 seconds. In contrast, polyacrylamide grinds that are not effectively ground will deviate relatively quickly from time 0, thus requiring additional time to achieve maximum drag reduction. This is exhibited by the blue and green lines. Note that the 98% of max for these 3 grinds varies from 2 seconds to 55 seconds to over 5 minutes. The latter is an example of extended hydration time and can impact hydraulic efficiency, as the product or a suspension comprising such a pan, when pumped, is not fully yielded. It does not reduce hydraulics. The time exhibited by the green line may even indicate partial hydration upon entering the formation, thus the potential for damage. The Ultra DR SP products are sized to perform in field brines ranging from freshwater to as high as 250,000 TDS. In addition, they'll perform in the presence of multivalent cations up to 20,000 TDS. While the TDS for the SP1 and SP2 shown in the table are nearly equal, the difference is the concentration of the multivalent cations. So the first two lines show the recommended field brine concentrations for each Ultra DR SP product. The last two lines in the table show the usage concentration as tested for this presentation. In these brine environments, Ultra DR SP products will generate greater than 70% drag reduction. So in the next few slides, I'll show flow loop results for the Ultra DR SP products using the brines and parameters shown in these tables. Simulating field brines, the Ultra DR SP products are added to the synthetic brine shown in the upper table. With the exception of the nearly fresh brine, which is number 1, all encompass cations of calcium, magnesium, iron, strontium, barium, and boron. The anions include nitrate and sulfate. The hardness for these brines vary from less than 10 to 40,000 milligrams per liter. The maximum iron approximates 80 milligrams per liter, and boron as high as 10 milligrams per liter. For simulating field hydraulics, we at TBC-Brinadd use our own flow loop. This includes a 12-foot straight pipe with 4-foot curved entrance and exit half-inch tubing. At 14.2 gallons per minute, this loop generates Reynolds numbers ranging from 100,000 to 150,000. This is brine dependent. The latter equates to approximately 4.5 inch by 7 inch pipe in the field. As an example of shear rate, we approximate 8,500 reciprocal seconds for a 50,000 to 86,000 TDS brine. The Ultra DR SP dry products are dispersed in 250 mils of brine, as shown above, and sheared at 1,000 RPM for 75 seconds before introducing into the 8-gallon reservoir, where then they are immediately circulated to start a flow loop test. So let's look at a few results. So starting with Ultra DR SP1, these are formulated for use up to 100,000 TDS brines of low multivalent cations. These charts, the results, compare SP1 in 10,000 to 86,000 K brines dosed at 0.75 and 1 ppt, 1.25 and 1.5 ppt. These are designated by the red and blue lines. In both brines, drag reduction is sustained for greater than 70% for 10 minutes. Also note that this product achieves nearly complete hydration in less than 2 seconds, as shown by their 98% maximum DR values. Next, the Ultra DR SP2. These are formulated for use to up to 100,000 K brines of low multivalent cations. These charts compare SP2 in 10,000 for reference and 113,000 TDS brine. They're dosed at 0.75 to 1 ppt, 1.5 and 1.75 ppt, again shown by the red and blue lines. In both brines, drag reduction is sustained for greater than 70% for 10 minutes. This product, again, achieves nearly complete hydration in less than 2 seconds, shown by their 98% maximum DR value. Last, our Ultra DR SP3, which is formulated for use for up to 250,000 TDS brines of elevated multivalent cations. These charts show and compare SP3 in 113,000 and 213,000 K brines dosed at 1.5 and 1.75 and 2.5 and 3.0 ppt. And these again shown by the red and blue lines. In both brines, drag reduction is sustained for greater than 70% for 10 minutes. And again, achieves nearly complete hydration in less than 2 seconds, as shown by their 98% maximum drag reduction value. So let's look at the viscosities. So for the next 3 slides, the viscosity of the Ultra DRSP products are contrasted in brines as shown in the previous table. All dispersed as dry and mixed for 90 seconds at 250 mils of the selected brine at 1,000 RPM. Each slick water solution is then transferred to our Grace M5600 dynamic viscometer, whereby viscosity is acquired at 80 degrees with 400 psi at a shear rate of 40 reciprocal seconds over a 15-minute period. So these results are for SP1 at loadings of 16 and 24 ppt. Viscosity is relatively elevated in 10,000, averaging 25 to 45 centipoise respectively, and in the 86K brine from 7 to 13 centipoise. At 4 and 8 ppt in a 10,000 brine, the viscosity ranges from 4 to 15 centipoise. In the 86,000 K brine, viscosity ranges from 2 to 4 centipoise, as expected for slick water. For our Ultra DR SP2, again at loadings of 16 and 24 ppt, in a 10,000 K brine, viscosity is stable. It averages 20 to 28 centipoise, and in the 113 K brine, the viscosity is stable at 7 and 12 centipoise respectively. At 4 and 8 ppt, in the 113 K brine, the viscosity ranges from 2 to 5 centipoise, 5 to 11 centipoise, as expected for slick water. And last, the Ultra DR SP3. And again, these results here are at loadings of 16 and 24 ppt. And they compare the SP3 in brines at 113 and 213,000 TDS. In the 113 brine, viscosity ranges from 6 to 9, and 12 to 15 respectively. In the 213 brine, viscosity ranges from 8 to 10 and 12 to 14. At 4 and 8 in 113,000 TDS brine, viscosity ranges from 2 to 5 and 6 to 13 at the same loading. And in the 213,000 brine, viscosity ranges again 2 to 5 and 5 to 6 centipoise, as expected for slick water. And last, we offer a family of dry and liquid breakers. They're trademarked as our Break-E products. Again, this will be the topic of our last webinar. All of the aforementioned polyacrylamides can be treated with our breakers to mitigate damage, especially at low temperature. We utilize earth metal or inorganic peroxides that deliver up to 20% available oxygen. As shown by the simulation on the right, an Ultra DR2 M4 suspension was dosed at 4 gallons per thousand, or 16 ppt. And the following breakers were compared. 2 ammonium peroxide breakers at 2 ppt, those are the blue lines, and our Break-E-C at 1.5 ppt, that is the red line, all at 125 degrees Fahrenheit. So when Break-E-C is compared to the baseline, which is the purple line, the viscosity was reduced to approximately 4 centipoise after 60 minutes of static aging. And with that, I'm going to turn it back over to Kimberly to show you the rest of our program.
Thank you, Mark. Very informative. We would like to invite you to future webinars. You are registered for this webinar. You will get an automatic email or an invitation to join us each Thursday at 10 a.m. for one of our next topics. Next week, we'll be touching base on our cross-linking additives. If you would like to share, feel free to forward an invite to your colleagues. You can register at our website, TBC-Brinadd.com/events tab. If you have any questions or comments, you can post them below. We will be responding and reaching out to each and every one of you to thank you. You will also get an email with the recording of today's webinar to watch the replay or to share with your colleagues. If you have any questions on pricing, you can reach your sales and marketing team at salesandmarketing@tbc-Brinadd.com. Thank you so much for your time. We will see you next Thursday at 10 a.m. for our cross-linking additives. Thank you.